So friends, now we are on the heterogeneous mixture, that is another type of impure substances mixture and heterogeneous mixture. So let's go on to heterogeneous mixture. So it's a type of mixture and a mixture is type of a impure substance. So let's go on to the heterogeneous mixture. It is a mixture in which its constituents are not mixed uniformly. That means you can see the physically distinct part, which I have already told you. So now let's just leave this heterogeneous and go on to its type, that is the suspension. It is a mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. That means there are physically distinct parts. That in a chalk powder solution you can see the chalk powder layer different from the water layer now. So that is how is it. The particles of the solute remain suspended throughout the bulk of the medium. That means you can see the particles throughout the bulk of the mediums. They are not mixed uniformly inside the medium. It is a heterogeneous mixture and it's a suspension. So it's a heterogeneous mixture first of all, and the particle size is very big to be seen by a naked eye. So big. I think I should not write it because it's in my notes as well. So, and can be separated by filtration. That means you can just get the chalk powder out when you filter it, the chalk powder solution, and chalk powder suspension, not the solution. And it's unstable as well. If you leave it for some time, the chalk particles will settle down, and it's unstable. And there might be a question rising: can it scatter a beam of light? As I told you earlier about the solution, it cannot. It cannot. But if it's a fresh solution, that means it has not settled yet. Then it can scatter a beam of light because it has a large particle size. But if it has settled down, then it cannot scatter a beam of light. So I think you've got a basic idea of, a full idea of heterogeneous mixture suspension. And then comes the colloid. It is another type of, heterogeneous mixture. And now, get out suspension. So colloid. Now you might be thinking, what would be if we mix some milk in the water? It would form a colloid, and a colloid has, a considerable particle size which is less than, the heterogeneous mixtures, but is more than the homogeneous mixtures. But you can still not see it from your naked eye, and it appears to be a solution because of its small particle size, but it is a heterogeneous mixture. That's your bad thinking result, I would say. But it's a heterogeneous mixture, not concentrating on the other things and going on to the topic. A colloid is a heterogeneous mixture which is not mixed uniformly. The same definition would come around, and let's discuss about colloids at a length. So colloids are having a small particle size, because of which they appear to be solutions or homogeneous mixtures, but they are actually heterogeneous mixtures. Then they are stable. That means if you leave it for a while, that milk will not settle down. And second thing, as it does not settle down, it can scatter a beam of light. And third, it can make the path of light visible because it can scatter a beam of light, so it came in the same point. I think you're getting to understand. It can scatter a beam of light. Scatter a beam of light. Then, particles cannot be separated through filtration. That I've already told you that even if you try to filter this milk and water, would you get the milk and the water separated? No, it would remain same. That means colloids cannot be separated by filtration. So now, I had a specific stress on that light scattering thing, light scattering. You might have seen it in many areas. For example, in a theater, if you would have seen a movie. In a movie, it's a very small beam of light, but it's extended, or it's its area is extended by these particles. It is the area is scattered. The beam of light is scattered to cover an area of such a big hall. It is because of those colloids. In that beam of light, you might have seen some dust particles that are shining. Those act as the colloid particles which scatter the beam of light so that it could cover such a hall, such a large area of the hall, and you can just see the movie. Oh, it's such a nice movie, and it's just because of colloid's property. And if I give you another example, I can give you an example that in a closed room, if light is entering from a small hole, sunlight is entering from a small hole, then you might have seen some dust particles shining in between. They seem like they are dancing, but they are not. And those are the colloid particles which are scattering the beam of light. Those small beam of light is being scattered. And other thing you can say is that recently I went to Sikkim side, and I saw the tidal effects. This light scattering effect is called the tidal effect. The tidal name is given after the scientist who discovered it, in honor of that scientist, Mr. Tidal. So I saw that tidal effect from the woods. In that the mist of the clouds and the fog was acting as the colloid in the air, and it was dispersing it. And it was a beautiful sight because the sunlight beams were scattered from inside the canopy. Like this, these are the two canopies, and from this, because of some fog and mist, the light was being scattered, and also it was looking so beautiful. And this was because of the colloid effect. So you can use the science everywhere. And next thing, if I go on for this colloidal solution, is that the dispersing medium and the dispersed phase. The dispersing medium. The dispersing medium is a colloid particle, and the dispersed phase is the substance which is dispersed by it. If I make you study it from the book, it is given on page number 18. And reading from the book, I would say that the solute compound or the dispersed particles in a compound form the dispersed phase. So if I give you an example from the solution, that the solute of the solution is the dispersed phase, and the solvent in a solution is dispersed medium. So which is dispersed is the phase, and which is dispersing is the medium. It is the solute and it is the solvent. And colloids are classified according to their states of the dispersing medium and the dispersed phase. So let me give you example from these of the NCERT. Those are given like in liquid. If the dispersed phase is a liquid and the dispersing medium is a gas, then the type of the colloid is aerosol. And the examples of the aerosol are fog, clouds, mist, etc. And if the dispersed phase is a solid and the dispersing medium is a gas, then the type of the colloid is again aerosol, and it can be smoke, automobile exhaust, etc. And if the dispersed phase is a gas and a dispersing medium is a liquid, then it's a foam. And examples of a foam can be shaving cream, etc. and so on. While noticing this table, I got to know something. not a very great discovery indeed, but something to be noticed by you all. There was not even a single case in which the dispersing medium was the gas and the dispersed phase also was the gas. This is because gas in gas forms a solution, that is the air. That is why it can never form a colloid. So I think you got it. And I think now you've understood the colloid. And thank you, friends. I hope you enjoyed this lesson. And if you want to get to know more about this chapter, about the separating techniques and so on, you can see other videos. And please remember to like, subscribe, share and visit my YouTube channel, Dashing Knowledge.